We'll now look at net change, and this is going to be similar to our discussion on position and velocity. So to start with, we need to suppose that q changes at some known rate, q prime. Then we can predict values of q by adding our initial value of q plus the integral from 0 to t of q prime of x dx. So you can see how this relates to position and velocity and what we had to get from the velocity function to the position function. So let's do an example. Here we have a cell culture that starts at 100 cells at time t0 and grows exponentially by n prime of t equal to 90e to the minus 0.1 t. We want to know what the population is after 1 hour. So since we're going from 1 hour, we're going to integrate from 0 to 1 of 90 e to the 0.1 t dt. When we integrate this, we get negative 900 e to the minus 0.1 t. And remember, if you're multiplying something in the exponent of e, you divide by that number whenever we integrate. So 90 divided by that negative 0.1 gives us the 900. So this gives us negative 900 e to the minus 0.1 plus 900 e to the 0. And once we work this out, this is approximately 85.64. Keeping in mind that we started with 100 and now we have changed by 85.64, in about an hour, it's approximately 186 cells. To find the population after t hours, we would need to start with our initial value plus the integral from 0 to t of 90 e to the minus 0.1 x dx. So this is 100 minus 900 e to the minus 0.1 x evaluated between 0 and t. Sticking in the upper limit of t gives us negative 900 e to the minus 0.1 t, and sticking in the lower limit of 0 would give us 900. Since we're subtracting this negative 900, it would be plus. So we can predict the future value by 1000 minus 900 e to the minus 0.1 t. Finally, we want to know when there are 200 cells. So we have this nice formula that predicts how many cells are in there that we just found. 1000 minus 900 e to the minus 0.1 t, and we want to know when this is equal to 200. I can subtract 1000 from both sides. And that gives me negative 800 on the right. Dividing by negative 900 gives me 8 over 9 on the right. And next we're going to take ln of both sides. And then we can divide by the negative 0.1. And when we do this, we get approximately 1.17 hours, which does make sense. After an hour, we were around 186, so just a little bit longer should get us to 200.